I'm Barry Hunt. Welcome to Prescience. I'd like to thank everyone for joining us here today. And today we're going to launch a very special project, Violet, the world's most advanced ultraviolet robot. My dream and our mission at Prescience is to help lead the world to create safe spaces. Safe spaces in healthcare, safe spaces in long-term care, safe spaces in grocery stores, in schools, in classrooms, in warehouses and factories, everywhere.
That is my dream, to see all of the hospitals using prescient technology and engineered solutions to preventing hospital-acquired infections and also to prevent the spread of deadly viruses such as COVID-19.
I can't tell you what a thrill it is to help highlight Prescient. You know, COVID-19 has impacted almost every aspect of our life, but there are companies and visionaries like Prescient that are stepping up and changing the world as we know it, and they're adding value, and it's all homegrown and homemade. So I couldn't be more thrilled with this company and the mark they're making in Waterloo region, across Canada, and internationally.
When the pandemic hit around the world, and when it started in January 2020, Canada was not prepared. We had SARS in 2003. We thought we had learned. We had a Great Commission in 2006 and gave future generations lots of warnings on how to prepare. But there was a long gap, and we lost that preparedness. So in 2003, when we took very, very aggressive tactics, we eliminated SARS in 8 weeks. We started using N95 masks right away. We started putting air filtration into patient rooms. We hoarded off hallways in hospitals. We blocked off elevator access. So having the experience of SARS-1 that went through in 2003, that was obviously one of the things that led to my passion for engineered infection prevention. And when SARS-2 hit, it was easily recognizable. Once you know, for example, that COVID is airborne, it's easy to manage. And so we knew all the steps that we need to put in place. And it really was the impetus behind developing new products, new technologies, and getting the word out as fast as we could to people. Prevention of transmission of disease, whether it's in a hospital or whether it's in the public sphere during a pandemic, is an engineering exercise. It's air, water, and surface transmission that we need to prevent. We need to prevent exposure, and that's an engineering exercise. And bringing engineers together with infection prevention, with ID doctors, with epidemiologists, to all work together to prevent exposure is the key to success.
Been interested in kind of engineering solutions that didn't require manual intervention. I mean, you can clean, until the cows come home, but 1 minute after you leave, it's starting to decay already. So any opportunity where there is this kind of engineered solution that perpetually worked every day of the year, every second of the hour, etc., was interesting.
As soon as we look at an engineered solution, we can get 99.9999% or Six Sigma reliability. We can get very cost-effective solutions because we can do things repeatedly, consistently, over and over and over again at a very low cost. And we can build things into facilities, into hospitals, etc., that will last for decades and continue to provide that protection for decades. At Prescient, we believe in a holistic approach. So air, water, and surfaces, we need mitigation strategies and technologies for all of them. So together, they create safe spaces. You can use materials like copper on high-touch surfaces. You can use built-in fixed auto UV for things like bathrooms or offices where people are in it all the time. And then you can bring Violet, a device that can operate virtually 24/7 to make sure that all of your spaces are disinfected. So when you move to an autonomous, adaptive UV robot, you get a 40-to-1 cost benefit compared to existing manual processes. You get a 100-to-1 performance benefit.
Sometimes business as usual becomes anything but usual, and you need to adapt. Today, you need new ways of ensuring a safe and secure environment. Good news, the future just rolled in. Introducing Violet. Prescient UVC robots are the fastest, safest, smartest UVC robots in the world, delivering UVC light rays that destroy bacteria, mold, and viruses like COVID-19 on surfaces and in the air. Violet is a fully autonomous smart robot, delivering continuous disinfection, giving your staff the confidence and peace of mind they need. Machine vision and multiple sensors enable intelligent navigation, so Violet senses and adapts safely to people, turning off light panels or pausing until it's safe to continue. Programmed to get closer to walls and furniture, Violet's 3 banks of independently controlled UVC lights deliver a larger targeted dose of UVC, resulting in greater reach and disinfecting power. Violet moves 4 times faster and goes 4 times further than the competition, meaning the workplace can be continuously and repeatedly disinfected 24 hours a day. And best of all, there are no operators required. With smooth, stable operation, Violet's perfect for industrial, manufacturing, and distribution environments. Violet will integrate seamlessly into your operations, managing its own pathfinding, record-keeping, and power. When battery power runs low, Violet returns to base, rapidly self-charging and heading back out for the next round of disinfecting. Smarter, faster, further. Breathe easy. Violet is on the job.
UVC is a very well-known disinfectant. It's been around for over 100 years, and it works very, very well. Not only can it get virtually everywhere, and not only is there no residual chemical left, but when it delivers a targeted dose to kill bacteria and viruses, it kills. There's no ability of an organism to develop a resistance that can overcome the amount of UV light that we are delivering. Adaptive capability is needed because just putting a lamp into a room and flipping a switch does not ensure that all the areas are being disinfected. Whereas Violet travels to all of the areas and she delivers the targeted dose to all areas to eliminate shadows, to eliminate problems with distance, and she ensures that we have achieved the targeted dose that we're looking for on all surfaces in our field of view. Can you imagine what kind of a team that you would need to disinfect 99.9% of surfaces 24/7, multiple times a day, document it all, and make sure that you've got a targeted dose delivered to 99.9% of those surfaces? That would take an army to do that. That's what Violet does. When we started out to design Violet, we wanted to make sure that she was fully autonomous, that she didn't need interaction. She could also be called out anytime you needed, but otherwise she would run on whatever route that she would need. She wouldn't need any further interaction. She would document everything that she did. She would make sure she was always delivering a targeted dose. We wanted to make sure that she could go do her job quickly and reliably, and she could operate 24/7. That she could charge really, really fast so that she didn't have to take long coffee breaks, just short coffee breaks to take a little sip of juice. This is a real game changer.
I think Prescience chose Clearpath first and foremost because of our product's reliability and trust in the market. Prescience's needs were somewhat unique. They required a great deal of power to be provided. UV disinfection takes a lot of power if it's going to be truly effective. And at the same time, they needed the vehicle to continue to maintain its ability to charge autonomously. Anyone choosing the Prescience solution is, by default, getting the world-class support and product integrations that also come with the rest of the Clearpath and Auto family of products.
I think finally the world has woken up to the fact that infection control is something that we need to do each and every day. It affects every aspect of our lives.
If we had Prescient technology installed in every office, in every school, in every hospital, we could be operating near normal right now. Our lives would have little disruption. Our economy would be probably booming. We could go about our business almost as normal. So the really cool thing, I've been involved in trying to bring technologies and materials to bear to reduce infections in hospitals for a dozen years. And what I'm really amazed at and hopeful for the future is that government and engineers and industry have all responded during COVID. The general public has responded. People are changing, people are adopting technology, and people are looking at what is needed to keep the air safe, or the water safe, or the surfaces safe. And this is a fundamental shift. This is a shift that's global. And it's amazing to see that the whole world now is moving to calling COVID airborne, and to understanding that we need things like UV and automation and technology. And I don't see us ever going back. We're only going to go forward from here. If 2020 was a year of challenges, 2021 will be a year of solutions. And Violet is the first of our solutions that we're bringing forward, but Prescience is very, very pleased to have a number of solutions coming forward for 2021, and we hope you'll be there. I'd really, really like to thank NGen for, first of all, being proactive in reaching out to Canadian industry to tap the best and brightest across the country for a response to COVID. And of course, to thank them for choosing us as one of the innovators to develop an autonomous UV solution. I'd like to thank Ryan and his team at Clearpath Robotics. They have been incredible to work with. They have a fabulous platform, a great Waterloo region-based company, and we really couldn't have done it without you. So thank you everyone for attending today. It's been a real pleasure to let you know a little bit about Prescience, a little bit about our mission, and of course, all about Violet.
Okay. Well, welcome everybody, and that was different. I haven't done one of these before, but thank you very much everyone for attending, for joining us, and we couldn't be more thrilled to announce Violet and to thank everyone who's been involved, and thank you to Clearpath and Ryan and NGen and everyone. And I'd like to open it up to questions now, and then followed by a special announcement here towards the end. I really want to make that be worth sticking around for. So Daisy is holding up the first question we have here is, what type of disinfecting does Violet do? So Violet uses UV 254, which is the most popular version of UVC that's being used right now. And you have to be a little bit careful with UV 254 in that we don't want to expose people to it. So one of the real keys with Violet is she will only disinfect when in the direction where people are not. And so she has a vision system. She can identify and recognize people, and she can independently control her lamps on 3 different sides and only light up areas where people are not. So she's unique in that she can disinfect lightly occupied spaces by moving around people and only targeting areas where people will not be in the path of the light. Question number 2, how do I know how many robots my facility needs? Well, it depends on how large your facility is, how much space you have to cover, how many people are there, and what it is that you're trying to accomplish. So, for example, in hospitals, it's been quite common to just disinfect patient rooms in between patients. And so about once a week, a machine would be rolled into a patient room, you push a button and you disinfect that space. So with Violet, we would like to obviously see that a lot more often. We clean and disinfect patient rooms now on a daily basis, so once per day, and then in special cases, more than once per day, maybe twice a day. And that's something we would really like to see Violet doing in healthcare. is, probably twice a day or more often, more frequently, because she can run 24/7 and look after her own charging capabilities so that her needs. So she can just take a sip of juice whenever she needs it, and she can just continue to operate. So I think she can offer a lot more disinfection. As far as other spaces go, offices and stores and factories, I think it really depends on the occupancy and whether you're running 24 hours a day or 16 hours a day, and how interactive people are in that environment, as to how often you would want Violet to be operating. So I guess the short answer is it depends. um, Next question: how do you see Violet being used in hospitals and airports? So I have a special one for airports at the end I'd like to talk about, but just in general at the airports, circulating through all the lounges and all the common areas, after a flight goes and all the seats are emptied out, to come in and disinfect those areas. And then we have, again, a very special announcement at the end of the program, and we'll talk about a special application for airports. As far as hospitals go, I would like to see Violet continuously move throughout the facility, disinfecting, down the corridors, into the patient rooms, all the equipment rooms, the ORs, at least at the end of the operating day, but where possible between cases. And again, I think she can, offer a lot higher frequency of disinfection than we've had before. The other, main application, it would be for terminal discharges in hospitals, so that when a patient leaves a room and the discharge team is called to clean and disinfect that room, that Violet would become part of that disinfection team, and then the terminal discharge team, and then she would go in and disinfect that room when the staff has finished their job. Next question: how effective is Violet in a surgery center? Uh, she, we can set Violet to target different doses. So I guess it depends on what it is that you would like to look after. She delivers a targeted dose. So we can have, routine low dose, or we can have higher doses for certain cases. So, for example, if we're going to deliver UV for C. diff, we would deliver at 100 millijoules per square centimeter or higher. Typically, she may be set for about 50 millijoules per square centimeter. You may want to have her running very frequently up and down public areas at 20 millijoules per square centimeter, where she could travel a lot faster and further then. And 20 is believed to be appropriate for SARS-CoV-2, which causes COVID. So in the surgery center, she can be very effective. You can adjust that dose that you would want to deliver, and of course, you can schedule or call her on demand to treat any areas. Another question, Jay? Does the robot have capability of testing indoor air quality at zero 0.3, 0.25, and 10 parts per million? Today, no, but she can carry devices with her, and so one of the things we're going to be talking about a little bit later is the first add-on to Violet, the first backpack that we'll be providing Violet with. And certainly air quality sampling can be one of those things. And in addition to particulate sampling, CO2 sampling, for example, as a measure of how effective your ventilation is relative to your occupancy, is another one. And then the third one, the last one, I'm going to save until the end of the program. How does she know if people are present, especially if people are unconscious? So, okay, in good conscience, I probably wouldn't send her into an area where people are unconscious. But we would have. She can recognize people, and she can. Whether you're sleeping or whether you're moving, she can still identify people with her machine vision software. So some systems would just use a passive infrared detection, and then you would have some issues if people are not moving in the case of someone being unconscious. And so while Violet does have infrared sensing, that is strictly an additional layer of protection in addition to her machine vision. So using the AI, a camera system that we do have, we can recognize people even if they are sleeping or unconscious, and so they don't have to be in motion to be recognized. How long does the surface need to be exposed for effective disinfection? So that's a function of how intense your lights are, how close your lights are to the surface, the angle your lights are to the surface, and um, and then how long you want to deliver it is dependent on those three things and the dose that you want to achieve. So Violet calculates all of those things on the fly. So when we set a target dose for Violet, she knows how far away she is um, from a wall or from a bed or from a chair or a piece of furniture. And she knows at what speed she should travel, which she should slow down or even stop, or whether she can continue on or speed up. And she's doing those calculations all the time. It's built in generally into her route initially. So when you first lay out a map of an area that you want to do, say for example, the seventh floor of a hospital. You walk Violet through the hospital once. She has a map built, and you identify rooms, that you want to do, and set a schedule. You want to do rooms 1, 3, 7, and 9 on demand, or set her onto a route, and she will go through and recognize those areas. And again, on the fly, she can measure how far away she is from a target, and then she can determine that speed and the direction and orientation that she needs to deliver that targeted dose. Is Violet's UVC type of light the same as has been used in earlier UVC products? And to what degree has Ontario's Ministry of Health expressed their support of this new offering, given that the Ministry of Health now requires UVC consideration on capital projects? Ah, yeah, so the same type of light that has been used in hospital projects, especially here in Ontario, but all across Canada um, for a number of years now, actually since 2014, when they first started to introduce auto UV into healthcare facilities. So UV 254, it's the same frequency of light. There are additional wavelengths of light in the UVC spectrum that are coming online. Some that have a higher, safety efficacy profile, where you can have exposure to people a little longer than what you can for UV 254. But right now, we're using exactly the same wavelength, the same technology that's been used for over 100 years, actually. Does Violet have audit capabilities for risk management analysis? Yeah, so Violet records her route and the dose that she has delivered. And so you can track, on a daily basis or in real time, if you like, to know exactly what she's delivered. And she can report back on an app. To show you, for example, if you had 10 rooms for her to do, and she could only do 8 of the 10 because 2 were occupied, and there was, no opportunity to disinfect all of that room. And she could show you, we've done these 8 rooms, 2 are left to do, and be in the schedule to do when the next time that they're available. Maybe the door was closed, or she couldn't access it for some reason, and she can report that back. How long do you anticipate between order and shipment of units? And demand will play into that equation, I'm sure. Yes, of course it will. But we're 4 weeks from order to shipping, if at currently. But again, depending on the demand and how fast this ramps up, that might stretch. I expect it may stretch a little bit. there's a worldwide demand right now for for high quality UV lamps. And the manufacturers that have been in that world for many years, fairly large manufacturers, they have really tried to ramp up production, but they can't keep up with the worldwide demand right now. So in our company, for example, we try to order ahead to keep lamps in stock well in advance, but it is a supply chain issue right now with some very key components that go in, but currently 4 weeks. Why is our bulb setup done with square sides versus round? So if we were to just have a circular array of lamps, like most other companies have done, and most other just manual mobile devices have been in the past, where you just light up a circular array of 8 or 10 or 12 lamps, and it just spreads light all through a room, we would not be able to effectively and safely disinfect spaces where people were located. And so by orienting separate flat sides, we can direct the light flat to surfaces. Most walls are flat, most beds, most chairs. And so we can deliver more light at a better angle of incidence. And then we can light up at the right side. If somebody's on the left, we could pass by them, say we're 4 or 5 feet away and we're driving down a hallway. We can stay fairly close to the right side, and we can be disinfecting that wall as somebody's walking past on the left side. We couldn't do that if we had a circular array of lights and we're lighting everything up. One more, Jay. How long do the bulbs last, and how often do they have to be changed? Well, again, the answer is it depends on how much you're using them. And so Violet monitors the health of the lamps that are there, and we can test the lamps as well. So you would want to at least have an annual preventive maintenance for your robot, where you're evaluating the condition of the lamps. But if we do have a lamp that is underperforming, she is monitoring the current and out to each of those lamps, and she will know, can give you an early warning detection. But it typically you would think 2 to 3 years for lamp changeout. Yeah. So we're getting close to the end. I do want to make this announcement, and it's really cool. So we had talked about can we sample things in the air as we drive around with Violet, and the answer is yes. So with additional optional add-ons, we could measure particulate, we could measure CO2, but really cool, we could measure COVID in the air. So we're just I'd like to announce that we are working with Control BioCloud, which is a very cool Canadian company that's just launching technology now to detect COVID in the air. And that's a feature that we're going to add as an option to Violet, so that as she's driving around and roaming around airports or hospitals or long-term care centers or schools or office buildings, she can also be sampling the air continuously for SARS-2 in the air. And I'll just quickly show you what that looks like. So here's what Control BioCloud looks like. And essentially you have a safe or unsafe condition. And the Control BioCloud will give you an alarm and then send an email or give an alert. And Violet will be traveling around sampling to enable that. So we're very excited to be working with Control BioCloud to deliver that. So I can't think of a better combination than being able to sample an area, find COVID, and then be able to detect. We didn't get to everyone's questions today, but our team's going to stay on the webinar. If you have any questions that I didn't get to today, thanks so much for taking the time to join us to learn about Violet. 2020 was a year of challenges, and I urge everyone to make 2021 the year of solutions. So thank you, everyone. Stay safe.